unique natural number x that satisfies this rational equation. So that's what this means, folks. This means there exists unique, is what the exclam stands for, unique. And that would be a positive integer, okay? So the natural numbers are just the set of positive integers, 1, 2, 3, 4, and so on, okay? So this means that you're given, so this is given information. You can kind of use that in the problem to make the problem a little bit easier, okay? Now also notice that this fraction, 89/40, is reduced, which turns, I don't know if that's useful or not, but it is a reduced fraction. The numerator and the denominator are co-prime. Now, y'all, I've worked out most of this already, and I won't go through all the steps. It's fairly standard algebra. Right here, the common denominator is just going to be the product of the two denominators. You can see right here that x minus 3 times x gives you this x squared minus 3x term, and then x minus 1 times x minus 2 gives us x squared minus 3x plus 2. And this is just a very standard way to combine a pair of fractions into a single fraction with a common denominator. And also, I just did, in fact, a 2 was present everywhere, so I pulled that out. And so we get to this stage right here. Now, this was a little tough. If you just directly set this denominator equal to 40, you get a quadratic that doesn't factor, nicely. And you know that you have a natural number solution, so you wonder what's going on there. So what I did is I rewrote it like this. I brought the 2 down and divided by it. Remember, dividing by 1/2 is the same as multiplying by 2, as you see right here. So it turns out it's a little easier just to set, this fraction is reduced, and now there's no common factors up here, so we can write down x squared minus 3x plus 1 equals to 89. Now, again, this is a little unmotivated, I know, but just because this right-hand side is reduced, a reduced fraction, doesn't mean numerically that this variable left-hand side is reduced. Okay, it's the best way I know how to explain it, but it's still a little unsettling, how the approach here. Now, by the way, you may be asking yourself, why not just cross multiply? Well, you can, I think, just at this point right here, you could just cross multiply, but you get this massive quadratic equation with very large coefficients, and so this approach seems to save some labor. Now, so what happens right here? We get x squared minus 3x plus 1, or minus 88, minus 88. So this should be minus 88 right here. I subtracted 89 from both sides. Okay, and then I believe, let's take a look here. I think it factors nicely. If it does, let me just write it over here. If it's going to factor, it would have to look like this, right? X X, and we're looking for a pair of numbers that combine to give minus 3 here, and also via multiplication give you a negative 88. Keep in mind we are looking for a positive integer solution here. So just playing the game of, this is trial and error, but you will have minus 11 plus 8, right? And again, that's trial and error. You can use the quadratic formula if you don't feel like doing the trial and error. Okay, so what we get right here is x equals 11. Now notice x equals negative 8 appears to be a solution too, but we're just told to find a single positive natural number solution. So we're going to stick with this, x equals 11. Now let's come up and check. Before I circle the answer, let's come up here and check. So we have x equals 11. So what would that lead to right here? I may need some space here, folks. So that would lead to 11 over 10. right? Again, x equals 11 right here. 11 minus 1 is 10, plus 11 minus 2 is 9, so you have 9 over 8. Okay, and this is the check phase of the problem. We're actually checking to see if this sums up to this right-hand side. Okay, so again, the standard process here is you cross multiply, even though that's not technically the correct language. It's really analogous to this step right here where you do a crisscross applesauce sort of thing here. So this would lead to 8 times 11 is 88. 88. 9 times 10 is 90. So 90 right there, folks. And then, of course, the product of 8 and 10 is 80. And this is equal to what? 190 plus 88 is 178. Over 80. And folks, these have a common factor of 2, and that's really this 2 you see right here, which made this a little tricky. So this is equal to 89 over 40. It reduces to 89 over 40. Okay. So indeed, the x that we're looking for is x equals to 11. And it's, I think there may even be a rational solution to this thing, but we were given that you had a natural number solution. And again, folks, it's not like saying find x. You're being told that you have a natural number solution, and we've determined that single unique solution is 11. We've just shown it right here. And so you can kind of do what you want if this is a given versus it's saying find all real solutions or whatever. You know, this is a given. We use that given information to kind of save us a little bit of work right here. We didn't. The normal step right here in an algebra class is to cross multiply, and you would get 80x squared, 89x squared. You know what I mean? And you would have a 9x squared leading term quadratic to solve. Okay, and you guys may want to explore that, but what I showed you is intended to be kind of easier, although some of the steps weren't completely justified. Like, you know, why couldn't you just go straight and do it from here? And those are good questions, and I don't know if I have the answers, but I do know that writing it in this equivalent form gives us a quadratic that solves. And also, you could actually, if you wanted to, you could work with this piece right here. This piece, this bottom part, would be equivalent to x squared minus 4x plus 3 equals to 80. And that's fun. That will work out for you too. It's just doing it up like this saved us one step, but that would equal to 80, right? And then you would get negative 77 on the other side, and you would also get 11 as a solution to that. So this is another approach if you want to work with the denominator here. Again, multiply by 2, you get this statement right here, right? But this one was kind of ready to go once we established that this and this were equivalent. So anyway, that's all. Final answer is x equals 11.